I'm Thomas. I'm with the Android Developer Relations at Google.
And I'm Terence, same team. Same team as Thomas, and we are working with Gen AI on Android. I guess I'll just go. So today, for our talk, we split it up into 4 different categories. First, we'll talk a little bit about Gen AI on Android in general, some use cases and some ideas of how you can integrate Gen AI into your mobile, in this case, Android apps. Second, we have a little section to take a closer look at Gen AI on device. Third, we'll take a closer look at Gemini Cloud Inference for Android. And lastly, we'll have some time to look at developer tools, so Gemini in Android Studio. Before we start, just wanted a quick show of hands. Who here has thought about cool ideas for how to integrate Gen AI into your apps? Cool. So I would say like a good 40, 50%. Does anyone have any really cool ones that they're willing to share? Okay, that's okay. We'll go into more details. So first, let's go over the unique constraints for mobile devices and how Gen AI can help address some of those frustrations. Generally speaking, smartphones aren't always ideal to input large amounts of text. The software keyboard is convenient for short messages and quick replies, but it can be challenging to write like a long section of text due to just the size of the screen. Similarly, the smaller screen of a smartphone makes reading or consuming long text harder than on a larger screen. Some features powered by Gen AI can help improve the user experience in your application to address some of those concerns. So one way that Gen AI features can help is by enabling summarization of long texts or allowing your users to ask questions about documents to help them consume information. Gen AI can also help with smart replies, or basically suggesting replies to text messages or emails based on previous messages or based on the context of what you've already typed. It can rewrite a text message or email to change its tone or style, and it can also be used to generate like longer, like several paragraphs out of just a few quick bullet points of just quickly writing down what you had in your head. An advantage that smartphones do have over other platforms is access to a really good camera. And photos taken by the device's camera can be also used for prompting Gen AI models as well. Our vision for Gen AI on mobile is, today, Gen AI is mostly integrated in apps as the central feature. So think the Gemini app on Android as an example. And we believe that soon, Gen AI will enable new features in apps to power features unique to each app's core user journeys. So we are working with developers to make this a reality today, as you'll see later in the presentation. Finally, in the future, we believe that Gen AI will augment every user interaction and unlock personalization and intelligence in apps. So next, let's take a closer look at on-device Gen AI. On-device Gen AI can process prompts directly on your smartphone, tablet, or computer without any server calls. This offers several key advantages. Sensitive user data is processed locally on the device. The model offers full functionality, even with poor internet connectivity, potentially reduced latency, which enables real-time responsiveness. And lastly, there's no additional monetary cost for each inference because on-device Gen AI runs on the user's hardware, not on any like server chips. However, on-device Gen AI today does have some limitations that we'd like you to keep in mind. Devices typically possess less computational power than cloud servers, so the models intended for on-device are smaller, and thus results may have lower resolutions. We are generally looking at between 2 to 3 billion parameters for on-device models today, which is almost an order of magnitude smaller than cloud-based equivalents. Similarly, the context windows for on-device inference will also likely be smaller as well, and the model will be less generalized. So what are some of the implications then? This means that fine-tuning is critical in order to get production quality. Zero-shot performance of the model has lower accuracy compared to what you may be used to with larger models in the cloud. Lastly, it also means that the model is not going to excel at every single use case. So for example, we found that it's not as performant for open-ended conversation, so like chatbot use cases, or code generation. So what are some good use cases for on-device Gen AI then? So many apps like Google apps like Messages, Recorder, and Gboard, we've integrated with them to deliver features in their apps. So for example, with Messages, we've built an AI-generated smart messaging tool where it can rewrite your messages to have different tones like Shakespearean tone or summarization. Recorder, it's a summarization use case, Pixel Recorder app. So that one, you can record like a long recording, and from that transcript, it can generate a 3-bullet-point summary of your long recording. Next, I'd like to talk a little bit about Gemini Nano. It's the smallest on-device variant of Google's powerful Gemini language models, and it is the Android's foundational model of choice for building on-device Gen AI apps. It's integrated into the Android OS from Android 14 onwards through a service called AI Core, which is an Android OS system app. Developers can access this service using an AI Edge SDK API surface. Gemini Nano is already bringing delightful Gen AI user experiences for the Google Pixel 8 Pro and Samsung S24 series, and we look forward to bringing it to more Android devices in the near future. Many Google apps like Messages, Recorder, and Gboard, we talked a little bit about that just now, are already leveraging Gemini Nano to power delightful Gen AI features in their apps. As mentioned before, there are a lot of unique constraints unique to on-device models, and fine-tuning is often critical in order to get production quality results. So what is fine-tuning? Fine-tuning allows an app or service to customize a model's weights to perform some specific task that they're interested in. LoRa is a parameter-efficient technique used in fine-tuning that doesn't require changing the base model's weights. It instead adds another like LoRa block in order to customize the model for particular use cases. LoRa enables us to optimize Gemini Nano for different apps use cases, and while maintaining a single copy of the model on the device to serve all apps that use that model. So far, all apps that have integrated Gemini Nano in production have leveraged LoRa to improve performance. So why is fine-tuning so important for on-device models when cloud models can solve many of the use cases out of the box with just like simple prompt engineering? The answer lies in the constraints that on-device models face, and that includes model size and context window. So we often find that prompt engineering alone is not sufficient for these on-device models. So LoRa fine-tuning does make it possible for a small model like Gemini Nano to excel in particular use cases, such as smart replies in messages. Since LoRa training customizes the model's weights to perform specific tasks, you will need a clear use case and not too much variance in your training data in order to successfully train a LoRa. Generally speaking, you want to have at least 100 entries in the training data, and the customized model may be even more reliable when you have 1,000 entries in the training data. Remember that, as with most things with Gen AI, there's no strict right or wrong answer. Experiment with different subsets of your training data to see what will give you the best result. And keep in mind that you can use larger models, such as Gemini Pro or Ultra, to help you generate training samples as well. So you don't have to like write each one down from scratch. To showcase fine-tuning's effects on a specific use case, here's an example of generating a message with a given style before and after LoRa training, and this was provided by the Messages team. When "let's go for a walk" was given as an input, and the model was asked to rephrase the message in a lyrical tone, Gemini Nano with free prompting responded with, "let's take a stroll, let's explore the world, let's make memories, let's enjoy the view." It's already not bad, it's pretty good. However, with fine-tuning, Gemini Nano responded with, "let's roam and let our hearts beguile. Through meadows and fields we'll forever whirl. A walk of joy our spirits will heal. In nature's embrace we'll let our will prevail." What beautiful lyrics now. Gemini Nano even managed to make the lines rhyme. Similarly, when "it's truly amazing" was given as an input, and Nano was asked to rephrase that input in a Shakespearean tone, the free prompting alone responded with, "A wondrous marvel it is." Again, already quite good, not bad. But the fine-tuned model came back with, "It doth truly astound," in true Shakespearean fashion. So I hope that helps to give, put into context like how much fine-tuning can improve smaller on-device models for particular use cases. So now for the topic that folks may be interested in, developer access. Since its announcement in December 2023, Gemini Nano has been available to a select set of developer partners through our early access program. And we wanted to thank our incredible community for the overwhelming developer response. We are really humbled by that. And we're actively collaborating with developers who have compelling on-device GenAI use cases and have signed up for our early access program. In 2024, so this year, we'll be investing heavily to enable and potentially launch with more third-party apps. So we're now working closely with a few early adopters to ensure that we're creating the best APIs that unlock the most innovative experiences. So at I/O, we showcase some of these examples and the use cases that they are currently looking to build with Gemini Nano. So I'd like to show you a quick video of that today. Oh, okay. Click again. So one of these trailblazers is Patreon. They're building an experience that helps creators and fans rapidly catch up on unread messages in their community chats. So that's a quick demo of what they're building with us. And then another example is Grammarly. Their team has been able to experiment with Gemini Nano while building their smart suggestions feature, which is showcased here. So yeah, hope that gives you an idea of the partners that we're currently working with and what they're experimenting with Gemini Nano to build. With that, I'd like to pass it to Thomas to talk to you about Gemini Cloud Inference for Android.
Thank you, Terence. Great. So yeah, so we just talked about on-device GenAI and how to basically run the model directly on the device. There is also another option that is already available for everybody to try out, and that is the Gemini API. So Terence just talked about Gemini Nano, which is the smallest model of the Gemini API. And there are also models that are bigger that today, who knows what's going to happen in 10, 15 years from now, but today can definitely not fit on an Android phone, but that are available in the cloud. So it's specifically Gemini Pro and Gemini Flash, which are models that are ideal for a lot of different tasks, and definitely what I would recommend today if you want to try generative AI on Android. Some of the strong features of it is that they are actually multimodals. So you can not only use text to prompt them, but you can also include images, video, and even audio files. And there's also a very strong ecosystem of various libraries and frameworks that are already integrating them, especially for backend integration. And there are also some SDKs for mobile and specifically for Android, which I'm going to talk a little bit about today. So specifically, when we talk about those Gemini models, which models are we talking about? So today, I would say we have two big models. There is the Pro on one end. So Gemini 1.0 Pro was the first version of it. It was only text to text, so you could not use anything else but text to prompt it. And a few months after we launched Gemini Pro, we also launched Gemini 1.5 Pro, which supports images, audio, and video, and also has a context window of 1 million token. Actually, quick question for the audience who is familiar with context window, the concept of context window. Okay, great. Yeah, a few folks. All right, that's fine. I can explain. So the idea is that you are going to send some information to the model to generate a response. And the amount of information that you are sending can be evaluated in the number of tokens. So for text, it's pretty easy. A token is roughly 0.8 words, and it depends from one word to another. So 1 million token gives you an idea. It's basically 800,000 words, so a lot of text, and that translates a little bit differently for image and audio files or video files. But the idea is that you can send a lot of information to the model in addition of the prompt, like let's say, for instance, a whole document to generate your response. And at Google I/O, we also launched Gemini 1.5 Flash, which is very similar to 1.5 Pro, but it is faster and also more cost-effective. So I want to say today, if you want to start experimenting with the Gemini API, you probably want to start with Gemini 1.5 Flash. And so the best way to start is to actually go to Google AI Studio, which is something that we launched with Gemini last December. The way you can think about Gemini AI Studio is that it's a little bit of an IDE for your generative AI prompts. So it's a place where you can experiment with your prompts and look at the results. You can also very easily put multiple prompts and look at multiple results based on the changes that you put in each prompt. You can also easily upload images or even like video files or audio files, just drag and dropping them and having them as part of your prompt. And finally, you can also configure advanced settings and the temperature of the model. So the temperature, you should think a little bit about it as the creativity factor of the model. If you keep it to 0, you will pretty much always predictably have the same response from the model when you run a generation. And on the other end, if you increase the temperature, you can see something that will be very different every time you generate. And so I'll talk in a second about basic prompt techniques, but what you should keep in mind is that your first prompt is very likely not going to be your best prompt. And so there is definitely an effort that needs to be put in the prompt to make sure that you have the response that match exactly what you want. And the truth is that as much documentation as there are and techniques that are now more and more shared, at the end of the day, it's a little bit more an art than a science. So that makes Google AI Studio a very important tool when you are trying to experiment with Gen AI, because you will probably have to have multiple iterations of your prompt. So speaking about prompt techniques, I think the first one sounds a little bit obvious, but I think it's always important to start with that. You want to be as specific as you can with your prompt. And so here you can see that I basically ask for a summarization, and I could just say summarize this text, and that will probably work, but it's very important for the model to have a consistency, right? Because it's going to be used by your users in your app to provide a little bit more than just summarize this text. And so for instance, here I'm saying, okay, you should write it as a 3 bullet point summary, and you also want to make the sentence short and specific. And so just by specifying that, I'm gonna have some consistency across all the generations. I'm gonna have those 3 bullet points, and the sentences will be always short and always specific. Another thing that is also interesting to know is the concept of few-shot prompting, which can be intimidating when you encounter it for the first time. What it really means is that you're just providing a set of examples to the model along with your prompt. So here, I'm basically using the model for sentiment detection and sentiment analysis. And so you can see that in green, I have those 3 different examples of sentences and the sentiment that is associated to it. And then at the end, I put my sentence, and I basically prompt the model to provide me for the sentiment. To be very honest, I think for Gemini Pro or Gemini 1.5 Pro or Gemini 1.5 Flash, you probably don't need to provide a few shots here. The model is good enough and capable enough to output the sentiment right away. But if you are using something like Nano, for instance, few-shot prompting is something that is very important to try. And finally, and I think that's something that is definitely interesting in the context of application development, right, you're probably going to want to have some structured data as the output. And so the way to do that is to just simply ask the model, hey, I actually want some JSON output, or hey, I actually want some HTML. And so here I'm saying, okay, I want you to, for each given order, to return a JSON that has the following fields. So I guess, I don't know, it's a fast food menu, maybe, or order. But yeah, I basically specify all the fields. And then you can see that in the very last line, the order is a plain text English sentence. And the model is able to basically output properly formatted JSON with the actual key and the proper value that I define. So yeah, so it's pretty powerful. And finally, if you are using some image as part of prompt, it's always a good idea, especially if you have only one image, to put your image first and then put your text prompt after. That usually provides you with a better output. So yeah, that's kind of like the idea of like creating a prompt, refining it, use all those techniques, and I'm honestly just scratching the surface here. There is a lot of documentation a lot of information in the Gemini documentation if you want to learn more about prompting. But when you are pretty much satisfied with your prompt, it's the time to basically bring the SDK to your Android application. So first of all, you will stay in Google AI Studio, and there is basically a Get API Key button that you are going to click on that will provide you with a Gemini API key. Then you need to import your Gradle dependencies, so something pretty standard. And as soon as you sync your dependencies, then you have basically the SDK that is ready to use in your code. And so it's pretty much as simple as what you have on the screen right now if you want to get started. So first, you need to instantiate a generative model. You will have to basically say which model do you want to use. So if you only want to use text, maybe you can only use Gemini 1.0 Pro. But I would say more likely start with Gemini 1.5 Flash. It's probably a good model to get started. And then you need to pass your API key. So here I basically have, in the Gradle settings, I define my API key, and I have it imported directly in my code with the build config. And then after that, you will create a string with your prompt, and you will call the generative model.generateContent method function by just passing the prompt string. And you can see here that I've wrapped it in a coroutine scope, right? Because the generateContent method is actually a suspend function. But just with that, you basically can start generating some response directly in your Android application. So pretty straightforward to get started. And obviously, there is a lot of things that you can configure, but that code on the screen right here is basically enough to get you started. So let's start talking about some functions that are a little bit more advanced. There is another new feature that is available with the Gemini API called system instruction. And it's actually a pretty powerful feature. So I don't know if you've seen, but there is sometimes for some chatbot that you are using or some API that you are using, you can pass the be a very friendly assistant or be a very helpful assistant, and kind of like define that as the system instruction. That's often what it's called. So you can use that if you want to build an assistant chatbot, but if you are trying to go for something a little bit more specific, you can actually take advantage of this feature to define the persona or define the role of this language model that you're planning to use in your application. You can also use it to define the style or define the tone of the response. And finally, I was showing you how you can very easily generate JSON by basically saying the prompt, hey, return some JSON. You can also put that directly in the system instruction and say, I want only some JSON, or I want only some YAML as output. And so here, I basically try to give the chatbot the persona of a friendly tutor that would basically explain things to a 10-year-old. And so I'm asking, okay, what is the Milky Way? And so you can see the response, right? Imagine that you're looking up in the sky and you see a band of light stretching across it. and it's talking about the Milky Way, that is a giant spiral-shaped galaxy, et cetera, et cetera. So it is friendly, it is using words and concepts that are relatively easy to understand. Now, if I change it and I say, okay, you're not talking to a 10-year-old anymore. Now you are a very authoritative professor and you are talking to PhD students. I ask the same question, what is the Milky Way? So I don't know if you know this, but the first sentence is, the Milky Way, as you already know. I'm talking to a PhD student here. I don't have to explain you what the Milky Way is at the end of the day. You should already know. Is our home galaxy. You should know that. And then instead of talking of the spiral cloud, it's using word as ethereal and it's talking about dark matter. So all of those things are basically kind of like tweaked a little bit to follow the system instruction that I gave before. And obviously, those are relatively simple examples, right? But you can leverage the system instruction to unlock some pretty interesting use cases. So how do you use that in your app? How do you leverage it in your code? Well, you can see that what I presented before is pretty much the same as what we have here on the screen. The only thing that I changed is that I added this optional system instruction parameter. I'm using a content object, which is kind of like a way to define some content passed to the model. Here I only have some text, but you can potentially add bitmaps if you want to prompt with images. But here in the case of the system instruction, it only takes text, and I'm passing, you are an authoritative professor, et cetera, et cetera. And yeah, and then I ask what is the Milky Way, and it's enough to basically generate the response that I just showed you. So that was system instruction. Another advanced feature, a little bit more advanced than what I just talked about, that I think is really important and I'm personally super excited about, is this concept of function calling. I don't know if who in the room has experimented with function calling before? Not that many people. Okay, that's great. One person. That's great. I'll walk you through it. I think it's definitely, as an Android engineer, I think it's definitely something interesting to look into if you want to use generative AI. So what does it do? And the name is a little bit of a misnomer, but that's kind of the word that has been used in the industry. So you will see function calling everywhere now. But you should think about it as like providing some tools to the model to help with the generation. So the model on its own doesn't have necessarily access to things such as the weather forecast or things like order history or currency conversions or things like that. Even the date, the model doesn't necessarily know which date it is. Some chatbots are able to give you that, but the model doesn't. So what we are going to do is that we are going to augment the model capabilities by, when we are prompting the model, or where we are, I guess, instantiating the model, we are going to tell them, oh, by the way, I have a function that can, for instance, give you the weather forecast, or that can give you the date of the day. And you are going to provide the information about the function, what it does, and also the input and the output format. And the model will then know when you are asking something, oh, I have actually this tool that is available to me that I'm going to use to generate the response. So that's kind of like what I try to represent here. So you see how I basically provide the model. That's the kind of like a representation, a graph representing the code that I showed before. When I instantiate my generative model, I say, here is the model that I want to use. I give you my API key. I can add some configuration. And so now I'm also going to pass a list of tools, which are basically the functions that are available in my application. So it's some Kotlin code that you write in your app. And I'm going to tell the generative model, oh, by the way, I created those functions. They are here. They are in Kotlin. They are available. You can call them if you need them. So here, I took the example of a food ordering app to stay in the theme after the burger, the fast food order in JSON earlier. And so I have a function that basically gives you the order list. I have a function that gives you the date. And there is also a function that places an order. And I tell the model, here are those functions. By the way, I didn't show it here, but here is the input, here is the output. And so then, in my application, when I'm using the model, I can basically, as the user is, let's say, typing in a field, a question such as, did I order Indian food the last week? And if you pass that to the model, because I initialized it by passing those tools, the model will say, okay, you're asking me about the last week. Well, I don't know the date, so let me call the function that is actually giving me the date of the day. All right, now I have an idea of like what you are talking about the last week. Let me get the orders by calling the function getOrderList. And so then you will get a list of order, and the model with those information will be able to basically look at the list of restaurants that you ordered from and realize that actually, yes, you ordered Indian food from Nan & Curry last Tuesday, which is an interesting paradigm. Suddenly, you can like literally augment existing or create very easily features by having those building blocks already available in your application. And so then a next step could be very easily enable a placing order. Because here, at the end of the day, in the previous example, what I did is just augmenting the generation with some information that are provided by the functions that are called. But you can say, I want to actually place an order. And so the model, by saying, OK, if I said I was tasty, order it again tonight, the model can directly call place order and basically place the order for you. In practice, I would probably add an extra step of confirmation in your application to make sure that the order is actually meeting exactly what you want. But I think you get the idea here. Like you're literally taking advantage of building blocks existing in the app with the model. So pretty powerful feature. There is a lot of documentation in the Gemini app, so in the Gemini documentation, so I would recommend you to look into it if you are interested. And so I've been talking a lot about the Gemini API and the ai.google.dev website where you get all those information. There is another way, as of a few weeks ago, to access the Gemini API is to actually use it from Firebase. Who is using Firebase in their app? Okay, that's a lot of people. So you're already familiar with Firebase. If it's already integrated with your app, that's actually probably the best way to use it, especially if you are planning on using it in production. So today, the Gemini API via Firebase is available in preview through the Vertex AI for Firebase. But as soon as it's going to be in GA, that's probably going to be the best path to ship generative AI features to production with the Gemini API. And if you want to learn more, it's in the Firebase documentation. There is the Vertex AI SDK. And finally, I don't know if you follow that, we launched a Gemini API competition. So if you haven't tried Gemini API yet, if you are interested in trying it, I think it's the best time to do it. You have until early August to submit your app. And by the way, there is $50,000 for the best Android app. So just putting out there. And there is also a custom electric 1988 DeLorean for the grand prize. So that includes everything. It's not only Android, but the best app is also enlisted to win an electric DeLorean. And with that, I'm going to pass it to Terence to talk about Gemini and Android Studio.
Thanks, Thomas. Let's quickly cover Gemini and Android Studio. Android Studio is central to nearly every Android developer's daily workflow, as you might use every day. And it's so exciting to see how millions of Android developers create amazing experiences with Android APIs and Android Studio that ultimately touch billions of people and their devices. Last year, we introduced StudioBot as your AI code companion for Android. Thanks to your feedback, we've evolved our models, expanded to over 200 countries and territories, released it to stable, and brought it into the Gemini family of models in April, with the introduction of Gemini in Android Studio. Today, we'll show you how Gemini for Android Studio can take your Android development to the next level. Our vision is to responsibly use AI so you can spend more time on the aspects of development that you like and make the harder tasks easier for you. Gemini for Android Studio builds upon the intelligence of the latest Gemini models, layering on additional Android domain knowledge to ensure that we're giving you more accurate guidance aligned with the best practices that we just discussed. All of this is integrated directly into your Android Studio workflow. You can ask development questions in plain English to generate code, find relevant resources, learn best practices, and just save time in your development process. Of course, being integrated directly in Android Studio means that we're also able to include your current editor state in Gemini's context window, meaning that we're able to give answers which are directly relevant to the files that you're currently actively working on. We use this to provide intelligent autocomplete directly in the editor window, allowing Gemini to offer intelligent, predictive type ahead as you're implementing methods. We can even help explain build and runtime errors alongside suggested fixes, which can be applied with a single click. All of this is available to every user in Android Studio as part of the Jellyfish stable release. Gemini in Android Studio is still evolving, and we already have several exciting features that we encourage you to try, available in the Android Studio Koala beta. The first is code suggestions, which provides a natural language interface for transforming any class, method, or XML file. This is great for refactoring type operations, though the tool is versatile and can be used for a variety of editor tasks. Perhaps you are a new Kotlin developer and don't really feel too confident that your code is taking full advantage of the language's features. You can ask Gemini to rewrite your code and make it idiomatic. Or if you'd like to add a new composed preview to your application to test your layouts on large screens, but can't remember the syntax, just let Gemini know and it'll take care of it. You can even ask Gemini to translate your apps into other languages as well. We've also integrated Gemini into Studio's App Quality Insights panel, allowing you to send crashes from Play Vitals and Firebase Crashlytics to Gemini to analyze it. Since Gemini is aware of your project's code, it's able to analyze the stack trace, infer proximal cause of the crash, provide debugging steps, and in some cases, even directly recommend a fix as well. Once again, both of these features are available to developers today in the Koala beta. We'll soon be integrating Gemini 1.5's multimodal input capabilities into Android Studio, allowing you to send images to Gemini. For example, you can upload a wireframe mock from a designer and ask Gemini to build a fully functional composed layout for you. Or you can upload a screenshot of your app and ask it to make recommendations on how to make your app more accessible. These features are currently in early access preview with select developers, and we look forward to sharing them with the broader community soon. Everything that you've seen here is available to developers free of charge, while Gemini in Android Studio is in preview. Both Android Studio Jellyfish and Koala Beta are available for download from developer.android.com. To learn more about AI in Android, here is a link. And lastly, to stay in touch with the latest updates and get in touch with us, please scan the code. I think they'll have a form to fill out where you can share your contact information and stay tuned for the latest updates. With that, that's the end of our presentation. If you have questions or comments or anything, we can stay for a couple of minutes and try to answer them.